Question 3. A company makes doors for kitchen cupboards from 2 layers. The inside layer is wood, and its thickness is normally distributed with a mean 7 mm and a standard deviation 0.3 mm. The outside layer is plastic, and its thickness is normally distributed with a mean 3 mm and a standard deviation 0.16 mm. The thickness of the plastic is independent of thickness of the wood. Find the probability that a randomly chosen door has a total thickness of less than 9.5 millimeters. 2 layers. One is wood. The other is plastic. Let's use W follows normal distribution with a mean of 7, standard deviation 0.3. Plastic, let's use P, follows normal distribution with a mean 3, standard deviation 0.16. For the door, we will use D equals W plus P. E of D equals 7 plus 3 equals 10. Variance of D equals variance of W plus variance of P equals 0.3 squared plus 0.16 squared, 0.1156. So D follows normal distribution with a mean of 10 and a variance 0.1156. So the standard deviation of D equals square root 0.1156 equals 0.34. We are looking for the probability that a randomly chosen door has a total thickness of less than 9.5 millimeters. So probability of D less than 9.5 equals norm CDF from negative infinity to 9.5. Mean is 10, standard deviation is 0.34. Let's go to calculator. Enter. Answer is 0.707. 8 doors are to be packed into a box to send to a customer. The width of the box is 82 millimeters. The thickness of each door is independent. Find the probability that the total thickness of 8 doors is greater than the width of the box. D follows normal distribution with 10 and standard deviation 0.34. 8 doors, let's use B equals D1 plus D2 until D8. So E of B equals 8 times 10 equals 80. Variance of B equals, we will use this formula, which is the variance of D1 plus variance of D8 equals 8 times 0.34 squared equals 0.9248. So B follows normal distribution with a mean of 80, 0.9248 as the variance. So sigma equals square root 0.9248. We are looking for probability of this B greater than the width of the box, 82. B greater than 82. Let's go to norm CDF. 82 as the lower bound, positive infinity as the upper bound, 80 square root 0.9248 equals sigma equals square root 0.9248. Enter, enter. Answer is 0.0188. The company buys 2 new machines A and B to make the wooden layers. An employee claims that the layers from machine B are thinner than the layer from machine A. In order to test this claim, a random sample is taken from each machine. The 7 layers in the sample from machine A have a thickness in millimeters of this data. Find the mean and find unbiased estimate of the population variance. We will put this into spreadsheet. Go to menu, go to 4, go to 1. One variable statistics. X list is A. Frequency list is 1. Then enter. X bar equals 6.93. Unbiased estimate of population standard deviation is 0.43644. Let's add another page. We can go to variable to get this result out. Then square. Answer is 0.163. Go to variable, go to this result. Enter, enter. We got this X bar equals 6.93. S sub n minus 1 squared equals 0.163. The 8 layers in the sample from machine B have a mean thickness of 6.89 millimeters and S sub n minus 1 equals 0.31. Perform a suitable test at the 5% significance level to test the employee's claim. You may assume the thickness of the wooden layers from each machine are normally distributed with equal population variance. This is a 2-sample unpaired pooled t-test. HO, H1. Machine A, we will use mu A. Machine B, use mu B. Let's go back to check the claim. The layer from machine B are thinner than the layer from machine A. So mu A greater than mu B. Second step, we will put data into the calculator. Let's go to menu, go to 6, 7 to sample t-test. Then stats, not data. Then going down. H1 is mu1 greater than mu2. Pulled, yes. Then enter. We got p-value equals 0.416. T equals 0.217. df equals 13. Let's draw the conclusion. Since 0.416 is greater than 0.05, fail to reject HO. Let's go back check the claim. This is the claim. So not enough evidence to suggest that the layer from machine B are thinner than the layer from machine A. Not enough evidence to suggest that the layer of machine B is thinner than that of machine A.